reproduction potential travels. All right? Now remember, one of the other cells in the body that doesn't duplicate are the neurons. Okay? Because neurons, we tend to represent them like this. Okay? Where we've got the cell body, we've got our dendrite, got our axon, and then we've got our terminal end. This is not a cell that worries about cell reproduction. It doesn't worry about one cell making two. It does have to focus on its product. What is the only thing, or what is the only product a cell can make? A protein. So up here, I got a great big huge nucleus. Okay? Why does my nucleus need to be so huge in a nerve cell? A lot of
electrical.
A lot of the proteins, ribosomes, because they're going to play a part in making the protein. But think about this also. Do nerve cells ever stop? No.
They don't replicate, so that's
It's there till it dies. Its only job, the only thing it focuses on, is making a product. And it doesn't ever stop. Because nerve impulses rarely ever stop. Okay? That nerve system you've got, okay? I mean, I don't know about y'all like it? Yeah. Just saying. Okay? 7 days a week? 365? 366? If it can leave you? 24/7? Boom. Never. Until death. Okay? That's a lot of product that the cell has to make. Okay? So it has this big nucleus because it needs to make a lot of product. Now, in this case, because these are neurons, okay, that little vesicle of their product, okay, will travel down the axon, get to the terminal ends, all right, and these little vesicles will be there, and they have their product, the neurotransmitter. That's the name of their product. So, neurotransmitter. Now, the nerves can produce too much, too little, release too much, release too little. Okay? There are things that can go wrong with the neurotransmitters. All right? But for the most part, for our purposes, with the muscle contraction, we're going to find that once we have the little vesicle, these little vesicles are going to have that acetylcholine. If acetylcholine is the product that gets released, crosses the synapse, makes it to the ligand, do we need that transmitter staying attached to that receptor? No. Why? Or, if we think about what happens with that receptor has a gate. When the acetylcholine attaches to it, it opens the gate. If it opens the gate, what rushes in? my sodium. And if the acetylcholine doesn't go away, so to speak, okay, and stays on that ligand, which has the gate open, if it didn't go away, what would happen to my gate? It wouldn't close. And if it doesn't close, okay, that means sodium would continually rush in. One of two things can happen. Sodium supplies diminish. The muscle can't handle that contraction. Does that make sense? So, for skeletal muscle, it's important that that neurotransmitter gets broken down. Do y'all remember what it means when something ends in ASE? It's an enzyme. So therefore, what's the job of that enzyme? Yeah, any of them. They'll either break something down or help build something up. If I don't need that acetylcholine staying there, I need it to break down. So we get to have acetylcholinesterase. Say that one time. All right? Now, this helps prevent the acetylcholine, which means it would stop it from getting attached to the ligand, stop the gates from staying open, stop a depletion of the sodium, blah, 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 blah. All these events that would take place. Okay? So, here we go. Y'all ready? All right, here's what's going to happen. We're going to have the nerve spire. The nerve spire creates the action potential. The action potential will travel down the nerve to the terminal end. At the terminal end, we're going to see that contains the vesicles with the acetylcholine. When that gets activated, those vesicles attach to the membrane right there at the terminal end. They release their acetylcholine. Don't forget to notice that this requires the use of calcium. That's going to come back to us in part 2. When this happens and the acetylcholine crosses the synapse to the ligand, the gates open. When the gates open, the sodium rushes in. This is going to occur at this point that's known as the neuromuscular junction that we're also going to be termed, or term it to be also, a motor end plate. Why do I say the term motor? Something happens. I get movement. Therefore, it is a spinal nerve meeting that muscle. Question? Because I know you're all sitting there thinking, why do I need to know this?
Is the post-synaptic membrane like infrastructure closer to like it's part of the muscle, but is it kind of like looks more like a neuron membrane?
Well, what they're going to say is that from basically one side to one side, all of this area that would be able to come in contact with that nerve end is going to be post-synaptic. So basically from all the way over there to all the way over here would be considered post-synaptic. And it would be full of the ligand-gated receptors, so that it could take in all of that acetylcholine, because that's the only place it can get it. Once this has taken place, the acetylcholinesterase, say that 10 times, okay? The acetylcholinesterase is present. It will break down the acetylcholine into its component parts, which is acetyl and choline. Choline will basically return into the end of the nerve, make its way back up to the nerve cell body, be reused to make more acetylcholine. The acetyl portion makes its way into the fluids of the body because it's just vinegar, and you get rid of it. But y'all never think about muscle contraction and pain again, will you? I know I never have. Ever since I learned it, it's never been the same. Nor has a nerve impulse. But that's kind of cool if you think about it. Okay, break. Get up and go. Get up and make the acetylcholine work.